So probability theory is one of the fundamental theories of statistics, and as I mentioned earlier, that it deals and makes assumptions on random phenomena. Random phenomena such as the height of people. And the height of people vary randomly, but they converge on a mean. And that convergence is explained by the law of large numbers theorem, and also in terms of if you draw enough samples, then your variables are going to be normally. Well, here's a chart that supports the law of large numbers, and when something is a law, then that means that we have a mathematical proof that that it exists, and that is something that we can depend upon time after time after time. And the law of large numbers just says that after a large number of repeated trials, the results over time approach or converge on some expected value. So here we have one die rather, and it has been rolled, looks like 1,000 times, 1,000 trials. And each time that it was rolled, then the number on the top of the die was observed and written down, and this was done repeatedly over 1,000 times, and you can see that over time that it converged on 3.5. Well, clearly a die does not have a side that is 3.5, but in between 3 and 4 is where the average die will roll. So 3 and 4 are typical kinds of numbers, and hence some of the games of probability and gambling deal with the number 7. The central limit theorem has to do with the normal distribution of random variables, and it assumes that variables have some kind of what's called a specific dependence. That is, that the scores on these variables depend upon certain conditions to hold true. For example, height depends upon, for example, whether you're male or female, whether you had tall people in your family. That is there a genetic predisposition? It could be prenatal care. There are a lot of variables that are dependent upon the random variable height. So when you take height, for example, and you start measuring people, then if you measure enough of them, then it's going to converge on a particular mean. And so I have an applet here that I want to show you. Here we go. And in this applet, it's going to have us to roll 1 to 5 die or 5 die, and then we can do it anywhere from 1 to 10,000 times. So just to give you a picture here, I have 5 dice in my hand. I roll them and I add up the numbers, and those numbers add up to 18. So take those dice back up, and I shake them and I roll them again, and I have 13. So I keep doing this, and then let's say after 100 times it looks like this, and 200 times it looks like this, and 300 times, and so forth. And then we get, let's move it up to 10,000 times. And you can see that over a large span of trials, that the average score of these dice converge on a typical score, and that the distribution of those scores are normally distributed. So this is a purely random phenomena. We don't have any control on the value of the dice that land, but you see that there is this beautiful property of a random variable, and that is that it is normally distributed. And of course, in mathematics, there is a formula that describes a normal distribution, and a normal curve, which is something that we would draw over these values, is dependent upon two values. One is the mean of this distribution, and the other is the standard deviation, the variability in this distribution. So a normal curve is actually a family of curves. It's an infinite family of curves that have a unique mean and unique standard deviation. So there are as many normal curves as there are combinations of values for means and standard deviations, which, by the way, would be an infinite number.